Today we begin the first of 3 talks dealing mainly with the planet Mars, a planet rich in legend and fable and tradition on this planet, and a planet about which we have recently in the last few years discovered an astonishing amount of new information. But I would like to begin not with Mars, but with a discussion of the nearest planet to the Earth, Venus. Venus, remember, is covered with clouds. We cannot, if we go to a telescope such as this, or a much larger telescope, look through it and see any features on the surface of Venus. If I look through a telescope of this sort, which is a sort of typical 19th century telescope. Of course, usually they were not inside rooms, but in observatories, so you could look out. Actually, this is pointed out the window in the back of the Royal Institution, and I can see upside down Dent and Company across the street. Were Dent and Company not in the way, I could probably see some overcast in the London sky. On the rare occasions when the overcast were gone and it was night, I could see whatever tiny portion of the sky was in that little patch. Now, if you were to use such a telescope, this one is about 4 inches aperture. The diameter of the lens is 4 inches across. If you use a telescope like this, or a bigger one, say with an aperture or objective of that size, on reasonably clear days, you could make out Venus as a disk going through phases, shimmering, silvery, enigmatic, interesting. Prolonged scrutiny would reveal no details at all. Observers in the 18th and 19th century used the fact that you couldn't see anything on Venus to deduce all sorts of interesting information about Venus. The argument went like this. My goodness, I can't see a thing. Why can't I see a thing? Venus must be covered with clouds. What are clouds made out of? Water. Everybody knows that. Well, there must be a lot of water on Venus. There's a lot of water up in the atmosphere, then there must be a lot of water on the ground. Maybe there are swamps on Venus. And from there, it was but a short step to a Venus populated by dinosaurs and covered with ferns and like the Earth of a few 100 million years ago. Now, we all recognize that this argument, which was, by the way, presented by a Nobel laureate, is weak. And in fact, Venus is not covered, so far as we know, with swamps, ferns, or dinosaurs. But it indicates to us that astronomers are human like everybody else, and no matter how little data there is, they will find it irresistible to make guesses, or as they're sometimes called, hypotheses, about what the planets are like. As more data comes in, the range of speculation that's possible shrinks until eventually there comes one fine day when there is only one possible explanation of the data. In the case of Venus, what happened was that in 1956, American observers with a large radio telescope found to their astonishment that Venus was giving off very intense radiation. Not a radio station, but a so-called thermal spectrum. It was noise. But it seemed to indicate that somewhere on Venus, things were pretty hot. Was it in the atmosphere, clouds, high up in the ionosphere, on the surface. Where did the heat come from? A set of observations, including observations by the first spacecraft to fly by another planet, Mariner 2, in 1962, showed that the emission was coming from the surface. And we now know that Venus has a dense, thick atmosphere, rich in this molecule, which we recognize, I hope, from the last lecture as carbon dioxide, which holds in or traps the radiation which the planet likes to give off to space. Sunlight gets through the atmosphere of Venus, warms up the surface, but the infrared radiation from the surface has difficulty getting out because of the trapping influence of this gas, carbon dioxide, and small quantities of water. This is called a greenhouse effect, named after the way a greenhouse is supposed to work, but that isn't the way a greenhouse works, but never mind. It's another mistake rich in the tradition of this subject. Venus is, in fact, at an astonishingly high temperature, 900 degrees Fahrenheit, about 750 degrees Kelvin, even though it's only a little bit closer to the sun than the Earth is. And the greenhouse effect is almost entirely responsible for this high temperature. In addition, the pressure on the surface of Venus is 90 times the pressure in this room. We would be crushed by the pressure of the air on Venus. And the atmosphere, while it is mostly carbon dioxide and has some water, also contains quantities of unpleasant gases like hydrochloric acid, hydrofluoric acid, sulfuric acid, and the like. It's an exceptionally nasty place, and in fact, Venus is very much like the classical description of hell. If you want to know where hell is, it's the surface of Venus. The clouds of Venus, which are very interesting, are composed mostly of concentrated sulfuric acid. And it's not a nice place to go visiting to. Now, despite the dense clouds, we are beginning to gain information about the surface of Venus. How can we do that? There are two ways. One is using radar, which penetrates the clouds, strikes the surface, bounces back off the surface to the radio telescope on the Earth. Some places are bright in the radar image, some dark, and we get a picture of the surface of Venus. The other way is to actually land on the surface and take pictures and look around. So an early map of the surface of Venus looks something like the next picture. You can see some vague bright markings on the surface. Those are places which like to reflect radar waves. Were we to use a more advanced radar telescope, which has been developed as time goes on, we begin to get close-up details. So here is a portion of the surface of Venus, and we see places which are bright, places which are dark. This place we see here, which is bright, we can look at more closely, and it is a place which has been called Maxwell. Many of the bright prominent features on Venus are named after pioneers in the study of electricity and magnetism, because it is electricity and magnetism which is behind the use of radar telescopes. There's another lovely feature named after Michael Faraday, who gave a lecture at 6 lectures at the Royal Institution at this time, 150 years ago. Why is Maxwell bright? Well, it may be a mountainous area which reflects radar very well. There are, we think, mountains on Venus, volcanoes, craters, valleys. The configuration of the surface of Venus is just beginning to be understood. The Soviet Union has successfully landed on the surface of Venus 2 unmanned spacecraft. This is a photograph taken by Venera 9, and we can see rocks, mottled ground, and away towards the top right, what looks like the horizon. There are rocks on the surface of Venus which don't look all that different from the surface of the Earth. That is extraordinary because the forces which erode rocks on the Earth don't exist on Venus. The principal reason that rocks are eroded on the Earth is because of running water. The surface of Venus is much too hot to have any liquid water at all. Another thing which erodes rocks on the Earth is wind-blown dust. But we know, both from theory and from direct observation, that the winds at the surface of Venus are very slow, even though they're very fast in the high atmosphere, and not enough to move dust. What then is rubbing down the rocks of Venus? It is a mystery. Two ideas which have been proposed are the terrible acids in the atmosphere, which may be slowly eating away the rocks, or it may be that the high surface temperature melts some low melting point component of the rocks, and so there is a slow change in shape of the rocks, a smoothing out as time goes on. Well, we don't yet have many pictures of the surface of Venus taken close up, but it may be that sometime in the next 5 or 10 years we will have views like this artist's conception of what the surface of Venus may be like. It may be very different from this as well. We are in the earliest stages of exploration. Now, the older astronomers not only proposed that Venus was a kind of swamp, some proposed that it was a vast desert like the Sahara, some proposed that it was an ocean of carbonated water, and some proposed that it was a vast planetary oil field. The fact that 4 such different ideas could all be held on the basis of the same data shows the enterprise of the astronomers in the absence of supporting evidence. We now have a good idea what Venus is like. It's not like the Earth. The analogy of the Earth was with us from the beginning because Venus is the same size and mass and approximate position in the solar system as the Earth. But Venus is a very different place. Now, these warnings are important when we start to study Mars, because Mars has also been thought to be a place in many respects like the Earth, that we have placed our hopes and fantasies, wishes and desires on. And we must be cautious that our wishes do not blind us to the reality of a planet. Now, exactly a century ago, in 1877, 2 discoveries were announced about Mars, which will dominate the rest of this talk. One is the announcement that there were canals on Mars, and the other, the announcement that 2 moons had been discovered going around Mars. Now, if we look at Mars through a telescope, we do not see a crisp, sharp, lovely image. We see a blob of a few colors which is changing its shape. It isn't even circular. Sometimes you see a little blob piece breaks off, as if Mars is dividing up. And you're lucky if you can see the polar cap, if the polar cap is visible. You're lucky if you can see any surface features. Mars is often a disappointment to the amateur astronomer looking at it for the first time. Where are all the features I've read about? I can't see any of them. The reason has to do with the Earth's atmosphere. The Earth's atmosphere is turbulent. It moves, and light which passes through it is bent. And it's a little bit like if you're having breakfast in the morning and there's a toaster between you and, let's say, your brother or sister. You're looking at the face of your brother and or sister, and suddenly the ear seems to waft off into space. The reason, fortunately, is not that there's anything wrong with your sibling's ear, but that the hot air rising from the toaster is distorting your view. And that's exactly what we have to deal with in looking at planets from the surface of the Earth, and is an excellent reason to get above the atmosphere of the Earth. But the observers of the last century were stuck on Earth, as we no longer are. And let me try to show you the problems which they had to deal with. We have here a modern map of Mars showing much more detail than the 19th century observers knew about, and a container of water above it. It's going to be illuminated from below and reflected in this mirror and go into the television camera. Meanwhile, Mr. Coates and I are going to dip our fingers in the water and make irregular waves, and the cameraman has defocused his camera, and this gives a faint sense of what Mars looks like through the telescope under ordinary seeing conditions with a reasonably good telescope. Maybe now the cameraman can focus up just a little bit, and occasionally an improvement, more detail. For just a moment you can see something like this, and then the Earth's atmosphere unsteadies, the image becomes less well focused, and the problem of the 19th century observer was to draw what he saw. If we could focus up again, I just can't resist doing this. Okay. Now, thank you. That was the problem. There was something to be seen, but only in fleeting glimpses, unpredictable glimpses. You couldn't photograph it because you couldn't tell the camera when to take the picture, because you didn't know when the atmosphere would be steady. The eye could remember when the atmosphere was steady, but the eye is not a perfect recording instrument. The best that can be seen by photography from the surface of the Earth is shown by pictures like this. Now, I'm going to show two photographs of Mars, and there are two features which I would like to show you, I'd like to call your attention to. I will, later in this talk and in the next talk, show what they are. In this picture, the dark feature at the very center is the darkest feature on Mars, and it is called Syrtis Major. We see that Mars has bright areas, it has dark areas, it has a polar cap made of some kind of snow. We know that the cap waxes and wanes with the seasons. There are occasional clouds. There's one here and one over here. It is a planet about half the size of the Earth. If we follow a certain feature, let's say this one, and see how long it takes for it to reappear as the planet rotates, we can find out what the length of the day is on Mars, and astonishingly, it's about 24 hours, just like here. The planet's about half the size of the Earth, so it has about a quarter the surface area, because the area is 4 pi r squared, as everyone in the audience surely knows, for a circle, for a sphere. And that's roughly comparable to the land area of the Earth. So even though Mars is smaller than the Earth, it is a big place for exploration. Things change. We see clouds. We see the polar caps change. And it's a reasonable place to think about what's the ground like? What's the atmosphere like? Could there be life? How did the planet come to be? Is it as old as the Earth? Questions which are difficult to approach if we are limited to this kind of detail. Here, the feature I'd like to call your attention to is this one right here called Solus Lacus, the lake of the sun. The people who named these features were very good at Greek and Latin, and those of us not so good at Greek and Latin have to struggle with the names. Now, these are photographs, but as I mentioned, much more detail can be obtained from drawings. Here now is a drawing of this same region, Solus Lacus, by a 19th and early 20th century observer named Antoniadi. And here we have, again, the Solus Lacus region, but much more detail in this picture. We see all sorts of little circles, and we see some hint of irregular, almost straight lines in this picture, but not lots of them. Also, we see coloration, sort of blue-purple to the dark areas, which we did not see in the previous photographs. Now, this same region was observed by others who saw it quite differently. Here is a drawing of Mars made by an American astronomer of the turn of the century named Percival Lowell. Here is Syrtis Major, the same region I showed you photographed before. But what is striking in this picture is all these funny straight lines. It looks like a cobweb. All over the disk, straight lines. They were called canals. And Lowell truly believed that they were canals. Here is a region near Solus Lacus, and we see that the whole Solus Lacus region is radiating with canals going in all sorts of directions. Again, the canals, the most striking aspect of the Lowell view of the planet. Now, what did Lowell believe these canals meant? Lowell believed the canals were canals. Reasonable enough idea. Lowell said that the straight lines could not possibly be the product of geology or meteorology. They had to be the product of biology. There were too many of them, they were too regular, they were too straight. They had to be produced by a race of intelligent beings that inhabited Mars. Lowell's idea was that Mars, being a small planet with a low gravity, water had escaped from the planet in large quantities and now was a parched and desiccated world. The intelligent inhabitants made a big effort, according to Lowell, to conserve what water there was, and so made a planet-girdling network of canals which captured the runoff in the spring from the polar caps and funneled them to the thirsty inhabitants of the equatorial cities of Mars. And as a result, we have a view of Mars, which we've made a little model of right here. And here we see, slightly out of focus, the blue water and the green verdure along the banks. And as we scan down the banks of the canal, we come to a joining with another canal in a place which Lowell liked to call an oasis. And there at the oasis we see something. Old Christmas ornaments, I believe Mr. Coates has told me they are, but they here represent an exotic Martian city. And people around the turn of the century seriously believed, and it's not an impossible idea, it's not ridiculous, but they seriously believed that there were high civilizations on Mars. Now, to give you an idea of Lowell's own views on the subject, he talked from this place in the year 1900-something, 1910, about the canals. And here's what he said on a Friday evening at the Royal Institution in 1910. He said, "To begin with, you should know that the lines you will see," that's the canals, "are certainties, not matters admitting of the slightest question, for all their strange regularity, and so seen by all those who, from the most prolonged and careful study, are qualified to speak." He says, others have described them as laid down with rule and compass. And not only I, says Lowell, but all of my assistants who worked for him have seen them thousands of times the same. Nor are they near the limit of vision in our air, in Lowell's special observatory in Flagstaff, Arizona, in America, which sometimes sets the planet against the sky as if etched in a steel engraving. Then he says, the technical word canals does not mean canals that are dug, but artificially fertilized strips of country connected with and vivified by the turning to such account of the melting of the polar cap. Lastly, I may say that by saying that organic life exists there, we do not mean human beings. Well, Mr. Lowell was very certain. The trouble is that lots of other astronomers tried to find the canals, and very few of them could, using equally good telescopes from equally good places. And so there got to be a lot of skepticism about the canals. Yet some astronomers saw them. What could they be due to? Well, let's do a little, very simple experiment. I have here some irregular pieces of polystyrene, this lightweight material, and here a felt black backdrop. And I'm going to try to just spill these on the backdrop in as random a way as I can. And since they fall through the air, that helps to randomize the patterns. Okay, now, I would like to ask you to look at this and tell me if you think you see some straight lines or small segments of straight lines. Is there anybody in the audience who sees little straight lines in this? Could you raise your hand, those of you who do? Lots of people see, no, not straight lines everywhere, but some straight lines. May I ask you to show me the straight line? It'll be very painless. Come on down. Show me what straight lines you see. There's one there, good. One there, one there, there, good. So now, how many pieces of polystyrene does each of your lines have?
Well, depends.
Roughly, how many?
About 6.
6, something like that. Good. Thank you very much. You've been a big help in deciding on what the canals of Mars may be about. I appreciate your help. Now, what is the lesson from this? It's that if you have an irregular pattern of fine detail, the eye, which enjoys order, sees apparent patterns where the little dots seem to connect up in a straight line. There's no way of making such an array of dots without occasionally seeing a straight line. So many observers thought that was the explanation of the canals. And we can here see a description of just such a point. Here is a region of Mars, which you can see has lots of lovely canals. And we're going to dissolve this region into another description. Here is a drawing, what a beautiful dissolve that was. A drawing of just the same region as seen by Antoniadi. And notice he sees virtually no straight lines, just disconnected fine detail. And now if we can dissolve back and forth, we can see how the eye might have drawn, in those moments of temporary good seeing, a straight line where there was only disconnected fine detail. But the problem is much worse than this, because we have now examined Mars closely with spacecraft, with much finer detail than Lowell could possibly have obtained. And we can look at all the regions where he drew canals. And here is a map which we drew at Cornell University of most of Lowell's canals against the features which are truly on Mars. And with one or two exceptions, there's no connection whatever. It isn't that little dots were strung up accidentally by Lowell and his followers. It's not that simple at all. There is nothing in most of the places where Lowell drew canals. And therefore, we must conclude that the canals of Mars are an indication of the inaccuracy of the human hand-eye-brain combination. We are not perfect observers. This is, by the way, a comment relevant to reports of unidentified flying objects as well. We do not report things always accurately, no matter how hard we try. And particularly when our emotions are involved, when we'd love to have a certain answer, our results are not of the highest accuracy. Now, there were two other kinds of arguments which Lowell used for life on Mars. One had to do with color, and the other had to do with seasonal changes. Now, Lowell and many other visual observers reported that the dark areas of Mars were green. We have not seen them green. We've seen in the photographs that they're sort of irregular gray color. But we can understand how it is that the dark areas may have been reported green. And we've prepared a little experiment, and let me describe what this experiment is about. First of all, the argument went like this. Lowell said, my goodness, the dark areas of Mars are green. What do I know on Earth that's green? Well, plants are green, so there are plants on Mars. That was the argument. You can see that's not a very good argument. It's about as good as the one for dinosaurs on Venus. But the question is, are the dark areas of Mars green? So what we've done here, we'll need the lights down a little bit, is to reconstruct obviously this doesn't look extremely much like Mars, but it's an irregular pattern, a dark area and a bright area next to each other. And I ask you to just check whether, in your view, I'll make a poll in a moment, whether in your view the right-hand part of this looks green. It certainly does to me. The left-hand part is a kind of pink. Now, what actually is happening here? What's happening is that we have a red irregular feature and a white disk. The white disk is surely white. But when we make the red pattern close to the white, the eye attributes to the neutral white region the complementary color. And the complementary color to red and orange is blue and green. So this is a kind of optical illusion, another failure of the human eye. Can I just take a brief poll? I won't be angry if nobody saw green, but will those who did see green please raise your hands? Virtually everybody. Thank you. So here again, a kind of problem with the human eye. Finally, Lowell saw changes on Mars. And here he was not mistaken. There's no doubt that there were changes. And we can see some of these changes. Here are three views of the same area of Mars, the Solus Locus area of Mars. And let's first do a close-up of the left-hand region. Good. Now, we see a large polar cap, which means it is winter. Right? In winter, the polar cap is large on Mars. In spring, it is small. We see a only moderate contrast between the bright and dark markings. Here is the Solus Locus region. Now, if we can dissolve into the next image, lovely. This is the same region, but now in spring. We see with a small polar cap. And now the contrast between bright and dark features is much greater. Lowell argued that what is happening here is that as the polar cap melts, the waters are carried down to the vegetation near the equator, and the vegetation grows, darkens the ground, and that's what's happening. These seasonal changes surely happen. We have them on photographs. Maybe they're due to vegetation. Maybe they're due to something else. That is a topic we'll cover in the next lecture. But let us now dissolve to the third view here. And here we see a vast, irregular, bright patch which has simply covered over the dark markings underneath. At the same season of the year, we see the small polar cap. Lowell correctly understood this to be a great dust storm, in which dust was carried by the Martian atmosphere over and obscuring the dark material. And those dust storms are important, and we will refer to them many times again. Now, I would like now to turn to the second great discovery of the year 1877. This one, a real discovery, the moons of Mars. Now, the moons of Mars had been an idea that was around for a long time. In fact, we can find it in the most unlikely places, in a story called Micromegas by Voltaire, and in the famous book by Jonathan Swift called Gulliver's Travels. It's an interesting place to find the moons of Mars, especially before they were discovered, but here it is. Volume 2, 1766, printed for C. Bathurst in Fleet Street. And this is something that happens to Gulliver when he goes to the floating aerial island of Laputa. This is not Lilliput, and it is not Brobdingnag, but Laputa. And it is probably good not to know Spanish to think of Laputa. The comment which Swift makes is the following. He says, they have extended their discoveries much farther than our astronomers in Europe. They have likewise discovered 2 lesser stars, or satellites, which revolve about Mars, and then describes the distances of the moons from Mars and how long they take to go around the planet. And these turn out to agree with a relation first announced by Johannes Kepler, and he says that this evidently shows them to be governed by the same law of gravitation that influences the other heavenly bodies. Now, how could Jonathan Swift have known about the moons of Mars? He didn't get the distances and the length of the month exactly right, but even there he came pretty close. How could he have gotten the existence of the moons of Mars correctly? How could he know? There are many proposals on this, including one that he was a Martian. But there is excellent evidence that Jonathan Swift was not a Martian. He was very much a terrestrial. Well, we have to go even earlier in history in order to answer that question. Unlike the novelists and writers of romantic fiction of today, people in Jonathan Swift's time knew something about science. And in particular, there was the idea which had been first formulated by Johannes Kepler in the 16th century, that Mars had 2 moons. Kepler's argument was tremendously simple and naive, and it went like this. He will use our orrery again. Kepler said, look, here's the Earth. It has 1 moon. Here's Jupiter. It has 4 moons, the 4 big moons that Galileo had discovered. That's all they knew then. Here's Mars in an intermediate position. Well, if it's in an intermediate position, it probably will have an intermediate number of moons, said Kepler. Why not? So what number is between 1 and 4? Well, that was well known in the 16th century, 2 or 3. But Kepler liked 2 because he liked geometrical progressions. He was a fan of geometrical progressions, 1, 2, 4, 8, 16. He loved such things. And so he said Mars has 2 moons. Now, it's a silly argument, and what's more, Jupiter doesn't have 4 moons. It has 12 or 14 or 20 or something like that. They're being discovered every month. And the argument breaks down even if it were a good argument. But Kepler was a famous astronomer, and for very good reasons. He was very clever. But he made mistakes, like everyone does. This was one of his mistakes. But what happened was people remembered the conclusion and forgot how silly the argument was. Said, Kepler says there are 2 moons. So people believed there were 2 moons, although no one had found them. Then in the year 1877, a new telescope was completed outside of Washington, D.C., at the United States Naval Observatory. And the astronomer Asaph Hall decided it would be a nice thing to go out and discover the 2 moons that everyone knew existed, but unfortunately no one had yet seen. And so he went out and looked, couldn't see anything, looked again, couldn't see anything, came home discouraged, and told his wife that this was foolhardy and he was giving up the search for the moons of Mars. His wife told him that she would hear no such thing, and he was to go right back to that telescope and find those moons of Mars. And he dutifully marched off to the telescope, and that very night found the first of the 2 moons of Mars. He called the 2 moons Phobos and Deimos, after the 2 horses which pulled the chariot of Mars, the god of war, in Roman and Greek mythology. And he was astonished on the first night to see the innermost moon in one position, and the next night to see it in quite a different position. And he couldn't figure out what was happening in putting together the observations on successive nights. And the reason for that problem is that Phobos, the innermost moon, is an extraordinary object doing an extraordinary kind of motion, which we will try to duplicate here. Here we have a model of Mars, and protruding on two metal pipes are two gray-covered spheres which represent Phobos and Deimos. Phobos at about the right distance from Mars, but Deimos would have to be somewhere out to here and would collide with the telescope and me and various things, so we've made it closer to the planet. Now, here we have the moons going around roughly at the right speed and Mars going around at roughly the right speed. And what do we see? We see that Phobos, the innermost moon, goes around Mars faster than Mars itself turns. Now, on the Earth, we're accustomed to objects rising in the east and setting in the west. Why do they do that? Because the Earth is turning from west to east. But on Mars, you would see something extraordinary. Since Phobos goes around faster than Mars does, Phobos would rise in the west and set in the east. And it would do it very fast. In fact, there are many times on Mars, if you live near the equator, when you could see Phobos rising in the west at sunset. It would then set and then rise again before dawn. You could see it rise, set, and rise. But only if you lived near the equator, because if you live near the pole, you can't see it. Mars is in the way because it's so close to Mars. Now let me see if I can stop the moons from revolving. That's very difficult. But now, the discovery of these two moons, first Phobos and then Deimos, was announced. It was thought to be important. Here is a reproduction of a page of the London Times for Tuesday, September 4th, 1877. And there, beneath a large map on the progress of the Bulgarian War, is a small article sent by telegraph on the satellites of Mars, saying that the observations that were made in Washington had been confirmed at the Paris Observatory, making them reliable. Now, the moons of Mars are too small to see with even such a telescope. All you can make out is a point of light. You cannot make out in the extended disk. They're tiny objects. So people interested in studying the moons, what could they do? More or less the only thing of interest was to observe the motion. And so this was done. And when the motion was observed, a strange thing was discovered. It was found by precision observations that the orbit that Phobos followed was not a perfect circle. It was instead something like a very faint spiral. The moon was slowly approaching the planet. And you can calculate at the present rate that Phobos approaches Mars when it will collide with Mars, and that will be in about 100 million years. We better stop it so it doesn't do it sooner than that. Now, 100 million years is far into the future, but still is short compared to the age of Mars in the solar system, which is about 4.5 American billions of years. And it's an interesting thought that Phobos will plummet into Mars and collide with it in the relatively near future, at least on the geological timescale, and suggests that other moons of Mars and other planets may have collided with them earlier in their history, and that great basins formed by such impacts might exist on the planets. And that's a topic for a later discussion as well. Now, why does Phobos have this strange spiraling motion? The Soviet astronomer I.S. Shklovsky is an extremely clever and creative astrophysicist, one of the best in the world, and he considered this question in around the year 1960. And he thought of all sorts of reasons it might do this, make this motion, calculated what would be required, and concluded that it couldn't happen. He then returned to the idea that Phobos was spiraling in for the same reason that artificial satellites in the Earth's atmosphere spiral in, because of drag by the thin atmosphere of Earth or Mars in the appropriate case. But Phobos is not a very large object, but we have a rough idea how big it was, and Shklovsky thought it was maybe 10 or 20 kilometers across. That's a very massive object. It's very far from Mars, so the atmosphere there must be very thin. How could that thin atmosphere slow down, drag this massive satellite? Well, the only solution Shklovsky decided was that the satellite wasn't as massive as we had thought, and the only way to have that is to have Phobos hollow. Shklovsky proposed that Phobos was an immense object 10 or 20 kilometers across, which was empty on the inside. He correctly pointed out that no natural object can be hollow in that way, from which he concluded that it was not a natural object. He proposed that Phobos was an artificial satellite of immense proportions, orbiting Mars. The biggest artificial satellite that we've managed is about the size of this auditorium, and therefore to make one the size of the inner city of London would require some civilization much more advanced than we are. And since there is no sign of such a civilization on Mars today, Shklovsky proposed that there once was such a civilization, but that it is now extinct. Now, that's a chain of argument which may remind you of some of the arguments of Percival Lowell, but notice that it's based upon observations that are at least real. Phobos does have that kind of spiral motion. Well, as a result, it would be very nice to take a close-up look at Phobos. What would an enormous artificial satellite 10 or 20 kilometers across look like? Right? That's something we surely like to know. And if it's not an artificial satellite, well, we could certainly find that out as well by examining close-up pictures of Phobos. Our first opportunity to do this came in 1971 when the United States put into orbit around Mars a spacecraft called Mariner 9. It was the first space vehicle to orbit another planet. It arrived in the midst of a great planet-girdling dust storm. There was essentially nothing whatever to be seen on Mars. I had previously proposed to the management of this mission that we should plan on looking at Phobos and Deimos, but they had a big book, and they looked in this book and said, nowhere in this book does it say anything about looking at Phobos and Deimos, so you can't look. And I thought about that a little bit, and then went back and said, the most likely origin of Phobos and Deimos is that they are captured asteroids. If we look at Phobos and Deimos, we then won't have to go to the asteroid belt, and we could save $200 million if you let us look. They said that that was a much more reasonable argument than the last one, and said maybe we could look. And then when we arrived at Mars and found there was nothing to be seen on Mars, they said, by all means, look, how nice of you to think of this. So we looked. And in late November of 1971, we obtained our first close-up view of Phobos, and it looked like this. Now, not much to see, right? But this is before the picture was computer contrast enhanced. And after, late that evening, we were able to make that same picture into this one. And what is it? Well, there seem to be a number of holes on it, which are probably craters, a giant one up at the top, and others in various places. And I don't know what a giant artificial satellite looks like, but this doesn't seem to be it. This looks more like a diseased potato. A few weeks later, we came very close to Phobos, about 5,000 kilometers away, and obtained this view. And we can see that it is an old, battered, irregular object. In fact, it turns out to be about as old as the solar system. It has seen large numbers of collisions. It does not seem to be an artificial satellite. And now, more recently, with the Viking mission, we have been able to obtain still closer up pictures. And here we can see a set of quite remarkable furrows and grooves running along here. In fact, the Viking spacecraft was able to be maneuvered within something like 100 kilometers of Phobos. We could have crashed it into Phobos if we wished to. It would have been stupid, of course, but we could have done it. And close-ups of these grooves have also been obtained. The reason for these furrows or grooves is still being debated. One interesting idea is that they are produced by the tides of Mars. The gravity of Mars is tearing at Phobos. And perhaps in time Phobos will be torn into pieces by these tides. And perhaps that is the origin of other fragmented features, for example, the rings of Saturn. It's a possibility. Also, Phobos is a very dark object, and now it appears to be made of organic material, and therefore may say something about the pre-biological organic chemistry in the early history of the solar system. It is a fascinating object. I'll say something more about it in a moment, but let's take a brief look at Deimos. You can see Deimos is not quite the same as Phobos. It does seem smoother. The two large craters that you see here have names. One of the marvelous things about this kind of exploration is we can name things. And we can put all our favorite people on these objects, provided they're dead. And so the two craters you see here have been named Voltaire and Swift, after Voltaire and Swift, for reasons which I've already described. Now, Phobos itself looks like this. This is a model of Phobos, made after Mariner 9, but not including any of the recent Viking data. And you can see what an irregular object it is. It has seen catastrophes. It is mute witness to cataclysms in the early solar system. Pieces have been broken off. Holes have been gouged. Things were very violent a long time ago in the vicinity of Phobos. Here is a great piece that's been carved out. In fact, some people think that Phobos and Deimos were once both part of the same object, which was split in some great catastrophe and broken into two satellites. Anyway, the big craters here we have named. We certainly wanted to name one after Hall. He discovered the moons, after all. But we also wanted to name one after Mrs. Hall, because there seems to be good evidence that they would not have been discovered without Mrs. Hall's urging. But we can't call both craters Hall and Hall, because then who will know which one we're talking about at any given moment? So we had to find out what Mrs. Hall's maiden name was before she became Mrs. Hall. Not so easy to do. And I once was giving a lecture at Harvard University in which I complained about how difficult this was. And a colleague of mine, Owen Gingerich, professor of the history of science at Harvard, who was in fact in England at this moment, stood up and said in a loud voice, "Angelina Stickney," he said, which is, in fact, Mrs. Hall's maiden name. And so we have two important features on Mars called Hall and Stickney. Hall is here, quite nice, large, but Stickney is here, and is in fact the largest feature, largest crater on Mars. And so I think we have done the appropriate kinds of commemoration. Now, there is a kind of lesson. The moons of Mars are without doubt of extremely great interest. And they are either captured asteroids or pieces left over from the formation of Mars. And if they are truly rich in organic matter, but even if they're not, they are objects well worth deep study. But the idea that they are artificial satellites is surely wrong. Just as the idea that Mars is covered with green vegetation is surely wrong. Just as the idea that Mars is circled with a network of canals constructed by a race of beings enamored of hydraulic engineering is wrong. These ideas were proposed before there was enough data. They were charming ideas. They were driven in part by our interest in the possibility of life elsewhere, and that is an important goal, to look for life elsewhere. But they also were, to some extent, distorted by our interest in finding life elsewhere. And there is a lesson. The lesson is, accept only the most rigorous standards of argument. Do not accept inadequate, poorly thought out, flawed arguments, especially where our emotions are involved. And that's a point which will be most important when we consider in subsequent lectures the possibility of life on the surface of Mars with more sophisticated instruments. Now, since these early times, many more observations about Mars have been found. For example, one such observation made from a high-altitude aircraft, not by a space vehicle, is a spectrum. The brightness of Mars versus wavelength. Brightness in the vertical scale here, wavelength in the horizontal, showing an absorption feature, this dip. It's very much like the spectral lines we talked about in the last lecture, and this is due to water. Not liquid water, but water chemically combined with the rocks and soil of Mars. It's a very big feature, and therefore means there's a great deal of water on Mars. Could some of it be in the liquid form? We don't know. But at this point, we don't know. But the existence of lots of water on Mars is a slight encouragement for those who like to think about the possibility of life there. The possibility of life on Mars has infused itself into Sunday supplements and science fiction and romantic novels, starting, by the way, with Percival Lowell's marvelous but erroneous popularization. And so, for example, it's possible to go to places as far afield as Peru and see, in this case on a door in a rural place in Peru, a sign which says, "Se vende marcianos," here we sell Martians. Now, if only that were literally true, we could save ourselves a great deal of effort by just going to Peru and purchasing a few Martians. But it turns out that those Martians are candy bars, rather like our Martians, both in the United States and the United Kingdom. There are Mars bars, which have nothing to do with Mars, so far as I know, except that Mars is thought to be a nice thing. The idea of looking for life on another planet is a splendid idea. It is properly a focus of our enthusiasms and our interests. But, as I said before, we must be very careful about the kinds of arguments we use. The only way to really find out about life on a planet like Mars is to go there. And therefore, it requires close-up space vehicle exploration of the planets.